Good afternoon. Today we are going to study D flip-flops. As you can see in the diagram, we are having this is the logic symbol of the D flip-flop. This is the circuit diagram of D flip-flop, and this is the truth table of SR flip-flop. And this truth table for D flip-flop, we are going to prove this. But before we come to this, let us have a look to the logic symbol, in which we are having a single D input. There is a clock which is edge triggered, and there are outputs Qn and Qn bar. And before coming to the circuit diagram, please have a look at the truth table of SR flip-flop. This is very important truth table which I have drawn, because from this truth table we are going to deduce the conclusion for our truth table of D flip-flop. In this truth table, there is a strong point you can see is that whenever you want to store 0, what we have to do is we have to make 0 s is equal to 0, r is equal to 1. The flip-flop will store 0 for us. And when we want to make when we want to the flip-flop to store 1, we have to simply make s is equal to 1, r is equal to 0. And also there is a important point that in this flip-flop, S and R inputs are always complement to each other. So this concept helps us in designing our circuit for D flip-flop from the SR flip-flop. As you can see, there is only a single input, and what we have done is we have connected an inverter to the S input. We just have connected an inverter to the S input, and hence it makes the D flip-flop. This D flip-flop is very commonly and widely used flip-flop. It's also known as data flip-flop. As in this flip-flop, what we have to do is we have to simply give the inputs, apply the clock, the data gets stored. Remove the clock, still the data will be stored for you. Now, in order to prove this truth table, first have a look at this. Here, as you can see that we are having one D input. Okay, this is S, R, and as we can see, these two are complement to each other. Whenever S will be 0, or when D will be 0, at that time S will be 0 and R will be 1. When D will be 1, at that time S will be 1 and R will be 0. Okay, now let us see and prove this truth table of D flip-flop. So initially the clock is 0. So as you can see, when there is no clock, it is 0. So just like in our earlier lectures we had studied, the flip-flop will maintain a state which is known as memory state, and there will be no change in the output which was stored in the earlier stage. So when there is no clock, this is the don't care condition, and this is memory state. There will be no change in the output. Now when we apply the clock, and now let us make D is equal to 0. So here when we apply the clock, make D is equal to 0, we can see here S will be 0, R will be 1. So from this truth table now, S will be 0, R 1. Now have a look at the output. This is Qn plus 1 is 0. So this is what we have written over here. The output is 0. Next, clock is 1. Now make D input as 1. So when we have made D input as 1, so here S will be 1 and R will be 0. So when S is 1, R is 0, we are getting output as 1. So here we are getting output as 1. And finally, since this is D flip-flop and we cannot have the S and R inputs as 1 1, which is an invalid state. So this is all about the D flip-flop is. In our next class, we are going to study about the JK flip-flop. Thank you.